Okay, this is lesson 11.8, area of circles. The area A of a circle is equal to pi times the square of its radius. So A equals pi times the radius squared. And there are two really neat animations that show why that formula works. So let's go ahead and look at the first one. Okay, so here the circle is split up into multiple parts, and when those are separated and put back together, they make what actually appears to be a parallelogram. This is the radius, and this is half of the circumference, since that's the whole circumference on the two sides. So the base is approximately pi r, the height is r, and when you multiply those, you get pi r squared. So that's one justification for that formula. The other one, here we have the radius, and then the whole distance around is 2 pi r, the circumference. And when that's split into parts, it roughly approximates a triangle that has a base of 2 pi r and a height of r. And then the area is 1/2 the base times the height. And when you simplify that, you get pi r squared. So that just shows why that formula for area works. So let's go ahead and see how we use this. So for example 1, find the area of each circle, round to the nearest 10. Okay, so the formula is A equals pi r squared. And here we have the radius is 4, so we'll just replace the r with 4. So 4 squared is 16, so that's 16 pi. And when we multiply that using the pi button on the calculator to the nearest 10th, that's about 50.3 square feet. For the second one, we're given the diameter. So if the diameter is 30, the radius is 15. So now we can use A equals pi r squared, and we'll replace the r with 15. So 15 squared is 225, so this is 225 pi. And then again, when you put this in the calculator using the pi button, to the nearest 10th, this is 706.9 square inches. Okay, so you're going to do 2 on your own, so pause the video, work through those 2 problems. When you're ready to check your answers, press play. This first one has an area of 113.1 square centimeters. And the second one has an area of 254.5 square inches. Alright, let's talk about sectors. The shaded region in the circle at the right is called a sector. Its area depends on the radius of the circle and on the measure of the central angle. A central angle is an angle with a vertex at the center of a circle and with sides that intersect the circle. It's basically a part of the circle, and it does have a point at the center. The area of a sector is really just a fraction of the area of the whole circle, and that fraction in particular is n over 360, where n is the degree measure of the central angle. So, for example, this looks like it's close to 90 degrees. A fraction of 90 over 360 would be 1/4, and that looks like it has about 1/4 of the area of the whole circle. So this formula should pretty much make sense. Whatever the fraction of 360 that the central angle is, the area will be the same fraction. Let's see what that looks like in an actual problem. Example 2 says, find the area of the shaded sector in the circle below, round to the nearest 10th. Well, the area, we'll use the formula for area of a circle, but we need to include this fraction in front of it. So the degrees out of 360, this one is 36 degrees. So 36 over 360 times pi r squared, and the radius is 6. Okay, if we reduce this, this is 1/10 times, and this is 36 pi. And then if we multiply those, we get to the nearest 10th about 11.3 square inches. Okay, there's a try it yourself problem for you to do as well. So pause the video, work through that problem. When you're ready to check your answer, press play. Alright, this sector has an area of 47.0 square inches. Okay. Lesson 11.9 is area of composite figures. A composite figure is made up of two or more shapes. To find the area of a composite figure, decompose the figure into shapes with areas you know how to find. Then find the sum of those areas. So these are some of the formulas that we've seen so far. We know how to find areas of each of those figures. So if we see something that looks funny, that doesn't look like a normal shape, we'll break it down into a combination of those shapes. So let's look at the first one. Find the area of each figure, round to the nearest tenth if necessary. Alright, this figure has already been divided for us by where the height is drawn. We can see two familiar shapes here. Here we have a trapezoid, and here we have a triangle. So what we'll do is find the area of each of those separately, and then we will add them together. So we'll need the formula for the area of a triangle, and we'll need the formula for the area of a trapezoid. So we have a trapezoid plus a triangle. Okay, so for the trapezoid, we have the formula 1/2 h times a plus b. And for the triangle, we have the formula 1/2 bh. Now be careful here. Notice that there's an h in both formulas and there's a b in both formulas. Do not assume that they are going to be the same. You have to make sure that you're very careful about each one separately. So let's look at the trapezoid. In the trapezoid, we have two bases. One of them is 7 meters, and the other one is 5 plus 7, or 12 meters. The height of the trapezoid is 7.5. So let's substitute those. The height is 7.5, and then the two bases are 7 and 12. For the triangle, the base is 10, and the height is 7.5. So you see here that the b here is not the same as the b here, so make sure that you keep those separate. Alright, when we find the area of the trapezoid, that comes out to 71.25, and then the area of the triangle comes out to 37.5. And when we add those together, we get 108.75. And our units are in meters, so this will be in square meters. Okay, let's look at B. This one definitely looks unusual. Here we have a large circle with some parts missing. A smaller circle, and then two identical triangles. So, what we want here is the large circle, and then we're going to subtract from that the small circle, and then also subtract two triangles. Okay, so the large circle, the formula for that's pi r squared. Small circle will also be pi r squared, but with a different radius, so we need to be careful with that. And then two triangles, which have a formula for area of 1/2 bh. Alright, let's substitute some numbers. For the large circle, the radius is, from the center to the edge, 8 inches, which is pi times 8 squared. For the small circle, if the diameter is 8, then the radius would be half of that, or 4. That's pi times 4 squared. And for the triangles, they each have a base of 8 and a height of 5. So, base of 8, height of 5. Alright, and just like we did before, we'll evaluate each of these separately. This is 64 pi, this is 16 pi, and this is 40. So now to the nearest tenth, 64 pi minus 16 pi minus 40 is 110.8 square inches. Okay. There are two try-it-yourself problems for you to do on your own. So pause the video, work through those two problems, and when you're ready to check your answers, press play. Okay. For the first one, you should have split this into half of a circle, and make sure you're very careful about what the radius is for that circle, and a triangle. And your total area should have come out to 72.6 square yards. For the second one, you should have split this into a rectangle, and then you're going to subtract a small rectangle, and then these two half circles together make a full circle. So if you wanted to, you could have actually combined those and thought of it as just subtracting one small circle. For this one, the total area should have come out to 6.9 square centimeters.